Good afternoon, everyone. Today, I will present research on the economic paradox of quantum imaging in precision medicine. Our focus is on how significant cost barriers are inadvertently deepening healthcare inequalities across various populations. This topic demands a critical and rigorous examination of technological advancement in relation to equitable access. Quantum imaging technologies offer truly revolutionary diagnostic capabilities. We are discussing molecular-level visualization and sensitivity that extends far beyond classical limits. These applications hold the potential to fundamentally transform the landscape of precision medicine. The promise includes earlier disease detection, more accurate prognoses, and highly personalized treatment strategies. Such advancements could theoretically lead to vastly improved patient outcomes and a more efficient healthcare system overall. However, the economic reality surrounding these technologies tells a very different and concerning story. The capital costs for a single installation frequently exceed $20 million, presenting an immediate and substantial barrier to entry. These advanced systems necessitate specialized cryogenic infrastructure, robust electromagnetic shielding, and a highly trained multidisciplinary personnel team. Consequently, their current deployment is largely confined to a select few elite healthcare facilities globally. Let me elaborate on the intricate cost structure involved. The initial investment for equipment alone can be 10 times higher than that of conventional MRI systems, setting a formidable financial hurdle. When factoring in the essential cryogenic infrastructure and complex electromagnetic shielding systems, the capital requirements become truly extraordinary. These are not optional components, but fundamental necessities for operation. Beyond the initial outlay, operational costs present equally challenging hurdles. Ongoing liquid helium maintenance, the salaries of specialized personnel, and limited reimbursement frameworks create persistent and significant financial burdens for institutions. This economic dynamic inevitably creates what we term healthcare access stratification. We are observing the emergence of three distinct tiers within the global healthcare landscape. At the apex are elite centers with full quantum imaging access, offering cutting-edge diagnostics. In the middle are standard facilities equipped with advanced classical imaging capabilities. At the base are underserved areas, which often possess only basic diagnostic capabilities, further exacerbating existing disparities. This tiered system directly impacts the quality of care available to different populations. The consequences of this stratification are profound and far-reaching. We are witnessing the creation of geographic diagnostic deserts, where advanced imaging is simply unavailable. This leads directly to outcome disparities that are increasingly based on socioeconomic status rather than medical need. Ultimately, this trend significantly widens the existing health equity gap. One might reasonably ask if costs will decrease over time, mirroring the trajectory of other advanced technologies. Unfortunately, for quantum imaging, this is unlikely to occur. The fundamental physics of quantum mechanics imposes inherent cost floors that are difficult to circumvent. Furthermore, the small market size limits the realization of significant economies of scale in production. Patent protection also reduces competitive pressures that might otherwise drive down prices. Crucially, the extensive infrastructure requirements remain constant, irrespective of production volume. Moreover, current investment incentives are fundamentally misaligned with equitable access goals. Developers naturally target affluent markets where returns on investment are more readily secured. This market dynamic means there is little inherent incentive for significant cost reduction efforts. We also face a circular barrier. Limited deployment prevents the accumulation of clinical evidence needed to justify broader adoption and investment. What about potential policy solutions? Attempted interventions face significant and inherent constraints. Public subsidies, while helpful, are often insufficient to address the scale of investment required. Reimbursement policies frequently remain inadequate to cover the true costs of these advanced procedures. Regulatory mandates are difficult to enforce effectively across diverse healthcare systems. Furthermore, international cooperation is often limited by complex intellectual property concerns, hindering collaborative efforts to reduce costs or expand access. We are confronted with a fundamental trade-off between fostering innovation and ensuring equity. Herein lies the true paradox. Precision medicine promises personalization, healthcare tailored to individual needs. Yet, the prohibitive costs of quantum imaging create systematic exclusion for vast segments of the population. The technology, in its current economic manifestation, actually contradicts its own stated equity goals. The long-term consequences of this trajectory are deeply troubling. We are effectively creating a two-tiered medical knowledge system. Future treatment protocols will increasingly assume diagnostic capabilities that most populations simply do not have access to. This divergence inevitably leads to significantly different healthcare quality trajectories globally. Let me summarize the main findings of this research. First, quantum imaging remains financially unviable for widespread, equitable deployment in the foreseeable future. Second, the cost structures create persistent access barriers, which are not temporary market inefficiencies. Third, technological advancement in this domain is currently deepening rather than reducing health inequality. Fourth, policy interventions face fundamental constraints that severely limit their effectiveness in addressing these core economic challenges. The reality check here is clear. Equitable access to quantum imaging is unlikely in the near term. This raises critical questions that society, policymakers, and the scientific community must urgently address. Should we prioritize frontier technologies accessible only to a select few? How do we effectively balance the imperative for innovation with the fundamental principle of health equity? What obligations exist for ensuring equitable access to life-changing diagnostics? Are we inadvertently creating permanent technological health stratification within our global society? Honest policy discourse requires acknowledging these uncomfortable economic realities without reservation. My final message is this: technological progress does not automatically equate to health equity. The key takeaway is that without deliberate and systemic intervention, quantum imaging will inevitably deepen existing health disparities rather than democratize precision medicine. The path forward demands a realistic assessment of achievable goals and explicit deliberation on research priorities and resource allocation. Thank you for your attention. I am happy to answer any questions you may have.